Good morning, ladies and gentlemen. This is David Jesudian, a geologist working in a Kuwait oil company in Kuwait, and with me here my colleague.
Good morning, everyone. My name is Mohammed Fikri. I am a petrophysicist in Weatherford, Kuwait.
And here we are present the poster for precise reservoir characterization, formation evaluation, and completion design using LWD high resolution ultrasonic imaging in North Kuwait for Cretaceous wells. This is a case study of one of the wells that has been drilled with new technology, ultrasonic imaging tool. Before we go into the technicals, I want to introduce a reservoir and also the objective to drill the well and some of the challenges that we are facing right now, which has been overcome by using the new technology. So the well we drilled has been drilled in one of the major reservoirs in North Kuwait, which is Sabria Madud Reservoir, which has been under production since 1950s. So this reservoir is a dermal anticline reservoir with an area of around 300 square kilometers, which is predominantly depletion dry. Currently under water injection, flood, also some of the dump flood wells have been used to sustain the pressure support. This is one of the major producing reservoir in North Kuwait production, with contributing more than 25% of the overall production. So in order to improve the sweep and also to sustain the production, we are using many new technologies in this field. One of the technology that we are using now is produce high and inject low to sustain the oil production. So the arrangement is to facilitate injector water to gravity segregate with effective upward oil sweep, resulting in improved oil recovery and reducing the water cuts in the long run. However, to minimize the water breakthrough and enhance production in horizontal wells, Kuwait Oil Company identified some attributes in ultrasonic among the latest technologies in the industry. So we have used this tool in one of our Madud reservoir to optimize the life of oil production. And Madud is an heterogeneous carbonate reservoir, which has a massive lateral and vertical variation in petrophysical properties like porosity, permeability, and phases, etc. So this objective of this well is to drill as a single oil producer horizontally with ISS, ICD, and ESP completions. So this tool has been used in this formation specifically to identify the flow zones within the reservoir for effective completions. The picture 1 is showing the location map in the Sabria field in the North Kuwait, and also showing the stratigraphic column of the field. And the figure 2 is geological stratigraphic setting of the Madud reservoir, which we are talking right now. And this Madud reservoir is overlain by Ahmadi shale, and the base of the Madud is Burgan. It's a huge clastic reservoir in Kuwait. Geology of I just want to highlight a few points on the geology of Sabria Madud reservoir. The Sabria structures are developed in the Cretaceous and with majority of faulting in tectonic structuring contemporaneous to the Cretaceous, late Cretaceous mischief and conformity. The structural uplift renewed in the tertiary and continued this day due to tectonic forces related to Zagras compressions. We have identified more than 100 faults and mapped over these fields, which shows the distribution of the mapped faults at the top of the Madud reservoir. So we are facing huge challenges in these reservoirs in beginning from well planning to drilling and completion, and also to sustain the oil production and minimize the water breakthrough. So one of the critical factors for the successful completion of this well is to have a very good ICD completion for these wells, and which is in turn related to identifying the high fracture intervals. So for this reason, the formation evaluation is very critical at understanding the water saturation, porosity, permeability of the reservoir, and also the compartmentalization and structural geology. is a key geology, is a key factors to decide on the well planning to completion of these wells. And also the poor connectivity will respond to acid frac and production decline fast. And in addition to this, we do have limitations in well placements, surface and subsurface constant. To mitigate some of these issues and also to have a better geological understanding and enhance oil production and minimize water cut, we are utilizing some of the latest technologies. One of the technology being the ultrasonic imaging tool, which Weatherford, and for the first time this well has been used for this well, and which proved to be very beneficial, and which in fact improved oil production for these wells. Definitely we will be using more of this kind of technology in our future wells to our targets and long-term objectives. So with that, I want to move on to the technical factors of this presentation, which will be done by my colleague Mr. Mohammed Fikri from Weatherford.
Thank you, Mr. David, for this informative introduction and the idea about the field. Moving to well location, in figure 3 we have here the structure map on top of Mawdud, showing the well located toward the southwestern part of the field, and the well planned to drill toward the southeast direction. The seismic cross-section showing the dipping expected to be flat or dipping up, and no fault expected in this well profile. In figure 4, this is a well trajectory cross-section view showing the distribution of the fracture along the well bore. Most of the fracture interpreted in this well bore, it's open fracture, either discontinuous or continuous open fracture, and showing here by color the density and the distribution along the well bore. Also some image example of the feature interpreted and picked from the image in the well bore. Figure 5, it's example for the bedding to 20. It is showing irregular bedding. We can distinguish from the unit above and below. Also the bedding is a suitable feature for preliminary structure depth calculation for the formation. Figure 6 is example of open fracture, which is the most feature we picked in this well bore. The image showing moderately to very steeply dipping dark color feature, which interpreted as an open fracture. Generally we can assume fluid. Figure 7, it's example of the rock texture and fabrics. We can see here some nodules, vug, representing the texture of the rock. And in figure 8, it's macro porosity example with a scale also 1 to 20. The secondary porosity analysis in combination with the additional open hole data like total porosity, water saturation, and permeability were used in this case study to identify the zonation based on the expected flowing from image and the open hole data. Moving to the analysis of the fracture and the bedding, in figure 9, here is a Deb-Azimuth-Schmidt plot showing the statistical analysis of the composite fracture reveals fracture trend to the northeast-southwest strike. In general, most of the identified fracture is Deb-Azimuth plot for the bedding data, showing the analysis showing the bedding surface trend to southeast, and the identified bedding surface have dip angle less than 1 degree. Moving to conclusion and result. Borehole image data, either electrical and acoustic, are a valuable source to get a better understanding of the reservoir and therefore to improve oil recovery. LWD imaging technology is developing quite fast nowadays, improving data quality. Tool reading captured from sourceless measurement, unlike conventional neutron-based tool, which will have positive impact on environment way forward. Ultrasonic imaging logs deliver a high-resolution acoustic image of the 360-degree borehole wall. This image covers 100% because the tool sent an ultrasonic wave out into the well bore, and the reflection of the wave from the entire borehole is recorded in the receiver. The tool was run successfully for the first time in Kuwait in our field Sabriya across highly complex carbonate Mawdud formation. Benchmark the result from ultrawave and sine wave, which is our the microresistivity imaging, proved the tool is functioning, meeting the objectives, and can replace the sine wave in case oil-based mud, as the ultrasonic image is suitable for both condition, the oil-based and water-based. Accurate azimuthal ultrasonic caliber, which is essential input for completion design and the bucker location. The tool output helps in the ICD, the inflow control device, completion by optimizing flow zones for increasing production to almost 30%. The fracture identified almost 30%. The fracture identified indicates open fracture, which is key factor in geological setting. Proper job planning to understand the well condition and customizing the tool assembly and parameters accordingly to eliminate the artifacts. Realization size to minimize the standoff effect and minimizing the lag time between drilling and logging to avoid severity of dehydration or mud cake formation, and proper hole conditioning before logging. Finally, this ultrasonic technology utilized in this well proved to be highly beneficial to enhance and sustain oil production by identifying flow zones, mitigating water production, and understanding carbonate geological framework for future development. At the end, I would like to thank all the participants in this poster and case study. I'd like to thank KOC for their support and all the data provided by all the participants, and I'd like to thank Weatherford as well. Finally, I want to thank the conference, GeoConvention, for this opportunity to allow us to present our poster.